Okay, so I've got some fireworks here. Uh, Rocket A is launched with some initial velocity, and then 4 seconds later, Rocket B is launched with the same velocity. And I want them to explode at the exact same time, 240 feet above. So A goes up and on this way back down, hits at the same time that B hits. So again, what I'm doing here is I'm going to call this T equals 0, and then this is T equals 4 when that one launches. Okay. And what I have here is I've got a position, I've got time, and I want to find the initial velocity. I don't really care about the final velocity at all. I just want to know, I want the time and the position to sync up. So the equation that I'm going to use here to sync those up is the following equation. Okay. That relates both position and time with this constant acceleration known as gravity, which I'm going to call G here. Okay, so let's start with rocket A. So this is what occurs at time equals 0, right? So at time equals 0, I launch rocket A. Okay, and um, it goes up, starts falling back down. Okay, and again, I want the times to kind of line up on this. Okay, so rocket A, again, I'm looking at the position at 240 feet. Okay, its initial position is going to be 0. Okay, its initial velocity, I don't know. I want to figure out. Its time here, I'm going to call t. Basically, I'm calling that time 0. So this is what's going on at that point. Okay, so time is what the time is. Okay, and then that's going to be minus 1/2. G is 32.2 for imperial units, t squared. So again, I don't know the time it takes. I don't know the initial velocity. Okay, that's basically what I want to figure out here. Okay, what I want is everything to line up with B. Okay, so I'm going to do the same equation for B. It is also going to explode at 240 feet. Okay, it's going to have the same velocity. Now, again, this guy's path basically begins at 4 seconds, right? I launched this guy 4 seconds later. So instead of T, I'm going to use T minus 4. So when the global clock of T equals 4 occurs here, its relative clock is at 0, right? That's right when it gets launched, right? So it's going to be T minus 4 because at 4 seconds, this guy is just getting launched, right? It's at its effective T equals 0. So that's why I use T minus 4 on this, okay? And then that's going to be minus 1/2, 32.2. And again, t minus 4 squared. So these are my two equations, okay? Just the only difference between them is that t minus 4, because I launch one 4 seconds later. But the t, t is the global time, okay? Okay. I put that t minus 4 in there so I can kind of manipulate, okay, this one's occurring 4 seconds later. Okay, so now the question becomes, at what time do they explode and at what velocity do they explode? Okay, so what I've done here is I've taken the top equation and I find the initial velocity as a function of t, and I get 240 plus 16.1 t squared all over t. And what I'm going to do is I'm going to plug that into the second equation, and I'm going to get 240 equals, instead of v naught, I'm going to use what I just found, t40 plus 16.1 t squared all over t times t minus 4 minus 16.1 times t minus 4 squared. So what I have here is I've got this huge equation. It's not that big, but a rather large equation. But the only unknown in it is t. So I can find t, and this is the t at which the explosion happens, where they're both at 240. One's on the downward cycle, one's on the upward cycle, and I get 6.348 seconds. So 6.3 seconds after rocket A it explodes, goes up, back down. This is only 2.3 seconds after rocket B gets fired. Remember, that's fired 4 seconds later. So that's on the way up, this one's on the way down. Now that I know that, I can plug that into the equation above, that V naught equation, plug in the 6.34 into that equation, and I can find that the velocity that these are launched at is actually 140 feet per second. So in the design of this, uh, of this fireworks show, I can figure out when actually to launch these and at what velocity to launch them so they explode at the point that I want them to explode. And again, I can only do this because I know gravity is a constant acceleration. Therefore, these algebraic constant acceleration equations can be used.